Hello, everybody, and welcome to Nature Connects. Nature Connects is the Massachusetts TNC webinar series that connects you with scientists, experts, and influencers from New England and around the world. I want to thank you so much for joining us today. I'm Massachusetts State Director and your host, Deb Markowitz. And today we're really lucky. We're going to be talking with the acclaimed scientist, Dr. Bill Mumaw. Bill is one of the world's leading experts in international environmental policy. And indeed, earlier this year, Bill spoke along Greta Thunberg and the Dalai Lama to discuss what can be done to slow down the threat of climate change before it's too late. We are extremely lucky that Bill has served for a decade as a trustee of the Massachusetts chapter of the Nature Conservancy. Bill is also a professor emeritus at the Fletcher School at Tufts University and a distinguished visiting scientist at Woodwell Climate Research Center. So today, Bill's going to talk with us about how forests' role in absorbing and storing carbon is essential for tackling climate change. He's going to discuss with us forests in the context of President Biden's 30 by 30 plan, as well as in the context of the IPCC and the IPBES reports. Now, if you don't know what they are, he's going to tell us about them. So if it's just gibberish to you, those are really those international scientific papers that are guiding us on climate change as a world. He'll also tell us about his recent paper, The World Scientists' Warning of a Climate Emergency, which was published in the journal Bioscience. You'll now hear from Bill, who will present for about 20 minutes, and then he'll take your questions. As you think of questions for Bill, please enter them in the Q&A box at the bottom of your screen. And let me say, we've already gotten a bunch by email. If you did email us in a question, please put it in again in that Q&A section so we're sure to have it in the queue. Bill has promised he's going to make us really think hard about these things, be a little provocative, and it's going to be an exciting program. So thank you again so much for joining us today. And Bill, let's dive in.
Oh, thank you very much, Deb. It's a delight to be here. So I guess what I need to do is to share my screen, right? Is that what I do?
Yes.
Okay, and then
So once it's shared, you say yes, and
I say slideshow, play from start.
I'm sure you've done this before.
Oh, does that work?
Yes. And Bill, let me just mention right before you start, but we pre-met to make sure we were all set up. And we talked about how, we're expecting so many people on this webinar. And yet he said, well, compared to his event with the Dalai Lama and, Greta, where was it 75,000 people were on that webinar and 1 million people who watched it afterwards?
It was a full bunch.
It was a whole bunch. Well, thank you so much for being with us. We really appreciate it.
Well, thank you for having me. And it's a great privilege, both as being a trustee and having worked with Andy Fenton and with
Laura
and Steve Long to actually be able to talk about this from the scientific point of view that I work from actually full time. Let me just briefly, this is the photo you had up there, which is, I think it's a wonderful photo because it shows a wonderfully biodiverse New England forest with not just trees, but you can see ferns in there. You can see there are all kinds of many other things. And that's what's really important for having forests that function. So in Spain in 2019, I attended the COP25, as it's called, the climate, all the governments are meeting there. And this poster just caught my eye. Don't call it change, call it climate emergency. And a group of 4 other scientists and I had published this paper in just a month before that meeting. And it was called The World Scientists' Warning of a Climate Emergency. And when we published it on that date, 11,000 scientists had joined in supporting that from 153 countries. And today it's over almost 14,000 from 156 countries. And the opening sentence is pretty unusual for a scientific article. Scientists have a moral obligation to clearly warn humanity of any catastrophic threat and to tell it like it is. So in that, we just have all these little graphics that just show how human activity has changed since 1979. I won't go through all of these. We don't have time, but you can go to the paper and find them. And most of the trends are not good. This is just showing the rise in the gases and the rise in fossil fuel subsidies and all kinds of things. And this shows the consequences. The middle or the second line down is showing all those downward curves are the melting of sea ice, the melting of Greenland, the melting of Antarctica, and the decline in glaciers. And these are just not great trends. And as you all know, temperatures have been rising. This is the temperature record. And 2020 ended up being tied with 2016 as the warmest on record. And the gray line, using the right-hand scale, shows the rise of carbon dioxide since 1880. And since carbon dioxide accounts for about 2/3 of the rise in temperature that we've been seeing by trapping heat, I'm going to focus on that, but we should remember there's another third of the warming that's coming from other sources. And that's why we have to have our natural systems working so hard. This is just a montage of things that happened in the past few years. The two upper right photos were taken in the Boston area. That's the one at the middle on the top is, that's the T station at the aquarium. And you can see what happened with the rising, with the higher sea levels and the rising, or excuse me, and the intense storm that we had there, which is shown on the right at Situate, just outside of Boston. Fires in California on the left, flooding in the bottom left in the southeast and in the Midwest. Intensification of precipitation shown in the bottom middle, 55% more rain coming in the top 1% of events in our part of the country. And in other parts of the world, we have droughts and we have these more intense hurricanes. So there's no question that things are changing. And let's just take a look at the global carbon cycle to get an understanding of why it's urgent that we work with our forests to address this problem. So the units here that you see along those little arrows are so-called gigatons per year. That's 1 billion metric tons of carbon as carbon dioxide. So if we look at this sources over here, we can see that about from the coal, oil, and gas reserves, we're emitting about 9.4 billion tons. And the little orange area shows the emissions coming from land change, from deforestation primarily. And so you add those together and you get 11 billion tons. And if you look at what appears in the atmosphere every year, it's only 5.1. So let me just repeat, we put in 11 and the increase is only 5.1 in the atmosphere. And the reason for that is that nature is helping us out in a big way. The 2.5 billion tons extra goes into the ocean and 3.4 billion tons extra goes into plants on land, primarily forest. So that's a total of 5.9 billion tons, and that makes up the difference. So the question, this has been known for a long time, but only more recently, starting about a decade ago, a group of scientists who I'd always worked on technological solutions, solar panels and all that sort of thing, electric vehicles. I began to realize what could happen if we were to increase the removal rate, that downward green arrow, for increasing the removals by plants on land, and in particular forests and wetlands, which I've been working on. So in October of 2018, at the request of governments, the Intergovernmental Panel on Climate Change published this report because in Paris, the Paris Agreement said we should not let temperatures rise more than 2 degrees and to make every effort to keep them below 1.5. And so the governments, after agreeing that this is what they wanted to do, said to the scientists, pray scientists, tell us, how do we stay below 1.5 degrees? And so here's just a direct quote from the report. Basically, to meet the 1.5-degree goal, global net anthropogenic carbon dioxide emissions must decline by about 45% from 2005 levels by 2030, reaching net zero around 2050. And what that means is that we must simultaneously reduce combustion emissions and increase removal of atmospheric carbon dioxide by all means possible. And so there are several ways to do that. So there's a lot of interest now and a lot of money going to atmospheric carbon removal by technology, something called direct air capture. Here's a picture of a machine in Switzerland. And the alternative are nature solutions. And one of those is something I'm going to talk about, which is proforestation. That is allowing forest to continue growing beginning with restoring the ones that have been damaged, but even the ones that we have right now, just maintaining them is not maintaining a stock of carbon. It is increasing all the time. And the thing to remember is that half the weight of wood is carbon. So if you see a bigger tree, it has more carbon than a little tree. And so the difference here between 545, oops, let me go back here, and 3.6 billion tons of carbon is huge. So this is what we're able to do today with direct air capture. Now that can be scaled up, but can it be scaled up in time to get us to zero net carbon by 2050? Or can we scale this up much faster to get there? So I'm going to focus on this slide. I'm going to focus on forests. And here was a paper that caught my eye in 2018. The largest 1% of trees in mature and older forests comprise 50% of forest biomass worldwide. This was a study of 48 forests of all types, tropical forests, boreal forests, our temperate forests, and half of the carbon was in the largest 1% of trees, except in most of the United States where it was only 30%. And the reason for that is because we don't let our forest grow large. We don't let our big trees let our trees become big trees. So here was another paper that appeared in 2018. Global forests and grasslands could store twice as much carbon as they currently do if managed differently. Boy, that would be good news. I mean, 3.6 billion tons being removed to 7.2, and our gap is is roughly 5 billion tons. That would be a really great deal. And then in a paper that I co-authored last year, in a study of 6 national forests in Oregon, 3% of the largest trees in those 6 national forests stored 42% of the carbon, just 3% of the trees. So that's not quite as dramatic as the worldwide number, but it's still pretty good. And the reason it isn't better than that is because those forests have been harvested heavily. Soils and wetlands can sequester substantially more carbon dioxide than they currently do. And I was the lead author of a paper with a group of wetland scientists in 2017 that made that case pretty strongly. And then one of my co-authors, Beverly Law, who's at the College of Forestry at Oregon State University, made this statement in a presentation she did, which was so succinct that I just thought I had to share it. Carbon in forest and soils is carbon not in the atmosphere. That's the point. So we want to get the amount of storage to be the greatest in a forest. That can be in the soils or it can be in the trees themselves. So this is a picture of me at Mohawk Trail State Forest here in Western Massachusetts. And I would argue that planting trees is good, but letting a tree like this grow is better. This tree is storing something like six tons of carbon, 6 or 7 tons of carbon. It's a white pine, and there are a lot, not a lot, but there are a number of them in the area that are doing that. And in 2019, I and 2 colleagues published a paper where we put all this information together with a lot of other research and said, you know, if we let forests grow, they would store a lot more carbon than they do, but we don't allow many of them to get big enough to do so. And And we realized that everybody talks about reforestation and afforestation, that is replanting a forest that's been cut down and planting new ones, but there was no word for letting a forest grow. And so we coined this term, proforestation. And forestation means growing forest, and proforestation, I guess, means you're in favor of it. So what we demonstrated was that if you let forests grow, forests, and allow them to reach their ecological potential for carbon storage in trees and soils, they get to what is optimal for whatever forest that is in whatever location it is. And larger trees accumulate the most atmospheric carbon over time, and they store that carbon in their wood. And so accumulation is the important number. So it may be that a group of younger trees may be absorbing carbon per acre faster than an acre of these big trees. But if you cut down these big trees to plant them with faster growing little trees, they have to first catch up to where this one is, which happens to be about 160 years old, and before it can take on more. So there's no point in getting rid of these trees just because they may have slowed down a little bit in their older years. By the way, this tree, 160, these white pines can live to well over 200 years, some 300. So and our average forest in Massachusetts are about 70. So we have a long ways to go. Now, let me just explain how some of the arguments for getting to zero net carbon by managing our forests more intensively and so forth are flawed. So these are looking at a whole bunch of white pines in Western Massachusetts. We were able to, Bob Leverett and I were able to reconstruct this figure of what it would be like per acre for a stand of white pines at ages 50, 100, and 150 years. And so think of this one down here. It turns out that at 50 years, that stand would have 22 tons of carbon per acre. And so if I do sustainable forest management, I'll cut that down, but I will reforest it. And in 50 years, if all goes well, I'll be back to 22 metric tons again. If I'd let it grow for that next 50 years, we would have 47 tons instead of 22. And so if I harvest it again and let it grow back, I'll be back at 22 tons after 150 years. But if I let it grow, I'd have almost 76 tons. So sustainable forest management doesn't get us anywhere. Offsets don't get us anywhere because the emissions are still going in the atmosphere and we're just not changing that total number. We have to be bringing it down. And when you have 76 tons as opposed to 22 tons, you've done a good job of bringing those numbers down. This is another study that's done by Bill Keaton and one of his colleagues up at the University of Vermont, looking at harvest practices. So you have about 10 different ways you can harvest well, I guess it's 8 different ways for harvesting a forest, and the one on the right is no management at all. And the light color is the amount that goes into wood products. And so there's this big claim going around now that, we can, the way to store more carbon is to cut down trees and put it into long-lived wood products. Well, as you can see, that doesn't store nearly as much carbon as letting the trees continue to grow. So that's a flawed argument that's being used. And again, in another paper that I participated in with Tara Hutteberg and Beverly Law, Tara is at Idaho, University of Idaho in the School of Forestry there. We did an analysis of Oregon since 1900. How much carbon was in that original forest, and where is it in 2015 was the most recent year we could get data. So in 115 years, it turns out that indeed, some of it is in long-lived wood products, 19%. 16% is in landfills. 65% of it, or generally 2/3, is in the atmosphere as carbon dioxide. So harvesting releases huge amounts of carbon dioxide. 85% of all the emissions associated with forests, including fires and insect damage and everything else, comes from harvesting. So one of the reasons that proforestation is so successful is you don't get harvest emissions. And the other is that the trees that otherwise would have been harvested continue to grow. So let's just take a look at to the northeast. This is a US Forest Service map. And when I spotted this, I was just stunned. The bright pink means low carbon density, about 18 tons of carbon per acre. And the dark green means 58 tons per acre. And so if you notice here in Western Massachusetts, this blob right here of dark green is the most largest high carbon density area in the whole northeastern United States. And the only other area to be comparable to it is the Adirondack Reserve over here. And so Massachusetts carbon density out here in Western Mass is 3 times that of Maine. And that's because Maine has never let its trees get big. They keep cutting them down for pulp and first for timber and then later for the last years as pulp. And I actually I'm also on the board of the Woodwell Climate Research Center, and I'm visiting scientists there as well. And I work closely with the scientists as we try to work these things out. And so I suggested that instead of just studying the Amazon, which is very cool, we should take a look at closer to home. So Wayne Walker, who heads up the carbon group at Woodwell, with the satellite data that he's able to use, came up with these figures. Here's Massachusetts. I find it a little confusing because the dark colors are basically non-forested areas. So here you see Boston, here you see Worcester, here you see Springfield. The bright yellow are the ones that have the highest carbon density. So north of the Quabbin here and sprinkled throughout this part of Massachusetts, Western Massachusetts, there's high carbon density. This strip along here, of course, is the Connecticut River, and that's mostly agricultural land. Then you can look at the changes. And so in this, red means losses, green means gains. And what you see is something that's really striking. While the greatest density is in Western Massachusetts, the greatest losses are in Western Massachusetts as well. And the greatest gains with the lowest densities to begin with are in Eastern Massachusetts. And we're working to try to figure out just why that's the case. So we actually have real numbers for this. And the US Forest Service publishes this. I found this wonderful set of tables. Looking at changes between 2003 and 2017, we find that the net change from state forests is a slight increase of about 61,000 tons of carbon. And other state lands about 176 for a total of about 237. But notice this, we lost 222 and we gained 460. And we'll see what that means. And then here's for the state-owned, non-state-owned land. So let me just show you what this means. So if the public lands had not lost carbon, had not lost this 222,000 tons, the gain would have been 683,000 tons instead of 238. Wow. For the non-state-owned lands, it's likewise, if there had been no carbon losses, this 1,729,000 tons of loss, so that's 1.7 million, we would have gained 6,000 tons and not just 2,500. And if we'd done it for the state as a whole, we would have gained almost 11,000 or 11 million tons instead of just 2.2 8 million tons. So that to me says we need to pay attention. And so the US Forest Service has these wonderful data sets showing the total land area of Massachusetts, about 5 million acres, and the forest land about 3 million acres. And it turns out that the forest lands, and they classify them, everything is timberland except what isn't. So 2,884 of these, 2.88 million acres are timberlands, meaning suitable for harvesting. Reserves are 125, and other land that's not forested is almost 2,000. So what does that mean? Just 2.5% of Massachusetts land is reserved, meaning that it cannot be cut on. And some of that is places like Cape Cod National Seashore. And so there's very little of our forested land that's protected. And you may be familiar with this 30 by 30 initiative, which both President Biden has proposed and is an international goal for the Convention on Biological Diversity, which is we will be protecting 30% of our land and waters by 2030, and eventually have a goal of 50% of those lands by 2050. We in Massachusetts are a long way from there. So I think the first place we ought to look is the public lands, and that we should create some strategic forest carbon reserves there first, and then work with the private landowners who don't want to have their land cut, and the land trusts for some others. So here's this largest 1% of trees in nature. In mature and older forests is 50% of the forest worldwide. But for New England, Bill Keaton up at the University of Vermont found that New England forests can store between 2.4 and 4.3 times more carbon. And there still exists some biodiverse stands of large old trees in New England. So on the left is Mohawk Trail State Forest in Massachusetts, and on the right is Canaan Mountain in Connecticut. And we have these areas sprinkled throughout the state. And here, for example, is there's also something like 10 or 12% stored in fallen trees as well, and both standing and fallen trees. Now, Deb mentioned IPBES, and IPBES is the International Panel on Biodiversity and Ecosystem Services, and they have pointed out that we are facing 1 million species extinction in this century at the rate things are going. Other studies have shown that since 1970, we have lost 40% of all the vertebrate animals on Earth. That is not numbers of species, but number of animals, fish in the sea, elephants, you name it. It's interesting, this study was done by DeGraaf in 2006, looking at the wildlife species richness in different aged forests down at the bottom. And you can see that if you look at the totals of all species, it's slightly higher in the older forests. And so there's a lot of harvesting of forests that have early successional habitat. But in fact, we are decreasing by our management practices the benefits of older forests. So birds are an indicator of ecosystem integrity. And in North America, they've declined by almost 3 billion birds. That's populations, not species, not numbers of species, but they're 2 billion. There's a 29% decline over what it was in 1970. And 1 billion of those losses are from forest species, which suggests maybe we're not managing our forests well. And current forest management practices are just not maintaining ecological integrity. And so we need more forests composed of our older, larger trees. So here are just some examples of species you find in older forests. There's a pileated woodpecker on the left, and there's a barred owl on the right. We've got a number of those, fortunately, around where I am out here in Western Mass. Now, Gifford Pinchot, who founded the US Forest Service, made this famous proclamation: the greatest good, conservation is to achieve the greatest good for the greatest number for the longest time. And so Harvard Forest Wildlands and Woodlands Initiative called for 10% wildlands and 90% woodlands as working timber producing forests. Here's a picture of the cover of their report. And what I would ask, what is the greater good today? And I would argue that mitigating and adapting to climate change and biodiversity loss is the greatest challenge. And so the greatest good would be to protect those systems that support the biodiversity, including our forests. So what are the strategies? I'm wrapping up here. Preventing deforestation, that's obvious. The draining of wetlands, prevent it. Soil loss, and restoring them. Those are essential. But pro-forestation management is far more effective than planting 1 trillion trees and is among the least costly options for removing and storing additional atmospheric carbon dioxide out of the atmosphere. So let it grow. This is a picture here of a typical New England forest, average age about 70 years. You can see the size of the trees there. Those trees could become much, much larger and much as they age. So growing forests is our urgent imperative. So with that, I'll stop and stop sharing my screen. And Deb, you're on.
Well, thank you so much. Like if you were in person, we'd all be giving you a big round of applause. I think people would be standing up. Really, the science here is so interesting. And I don't know if any of my, folks watching may recall that before being at the Nature Conservancy, I had a long career in public service in Vermont, where, like Massachusetts, we've got a lot of middle-aged trees. There was deforestation. It's everything was cut for the sheep, and it grew up all at the same time. And those small places where there's still old growth stands are very precious. And we're always thinking, how do we make sure our forests are working for us in Massachusetts and coming back, obviously, from Vermont. And I want to give a shout out to Bill Keaton. He was a colleague at the University of Vermont, does really great work. I'm glad to see you partner with him. I have so much to say in response, very stimulating. First of all, I hope that pro-forestation, how every year they announce new words in the dictionary?
Yes.
Maybe if everybody watching uses pro-forestation, we can get it into the dictionary, because it is a concept, a word that's so relevant at the moment. And, for me, your presentation really put our work at TNC into context. And, in Massachusetts and really across New England, the Nature Conservancy is leading the effort to ensure that the state climate plans incorporate the essential role that nature, and forest in particular, play in fighting climate change. And, and of course, we try to protect everything from urban trees to wild forests. And so the statistics about Massachusetts, I thought, was really interesting about where the additionality is happening. And of course, it's so important to inform forest management so that we can balance this incredible need to sequester and store carbon with all of the other values and products we get from our forests, which, have really driven a lot of the management practice before. And then, of course, I want to just say, as powerful as they are, forests alone can't fix climate change. There's no question this is an all of the above. We need to use the power of nature to remove carbon pollution and to store it, but we also can't lose sight of reducing the use of fossil fuels. Otherwise, we're just, not going to make it. We've got to be doing all things at once. So anyway, that's my top line thinking coming out of your very stimulating presentation. We've got a bunch of audience questions. Just as a reminder, as you think of questions for Bill, please enter them in the Q&A box at the bottom of your screen. And so I'm going to come to some of the questions we've collected. So if we continue to emit greenhouse gases on the same scale we are now, what do you see happening over the next 40 years?
Well, it all depends on, but it won't be good, that's for sure.
We figured.
And yes, I want to make it clear, we must simultaneously, I think I said it, that slide on the IPCC one, we must simultaneously reduce our emissions from all, not just fossil fuels, but every other way we emit carbon dioxide, steel making, everything we do. Uh, and, um, and at the same time, ramp up the capacity of nature. We have degraded nature so badly that it's limping along at kind of half speed. And the point is that there are so many, and as I said, I spent over 20 years working on the technological solutions and living them to the extent that I can in order to reduce emissions. But we can't solve it just with solar panels. We can't solve it with just electric vehicles. We cannot solve it with just proforestation. But we absolutely cannot do it without our forests. That is very clear, because they absorb so much, and even in their decrepit state, they absorb so much. And the reason it's an emergency is, as we warm the Earth, we're not only releasing carbon dioxide and methane from the permafrost in the Arctic, we are increasing respiration of forests in the temperate zones and the tropics, and therefore, the Amazon is absorbing a third less than it was 10 years ago.
So it's non-virtuous cycle. And we did get some questions about forest fires, because also with climate change, we're having more forest fires. And the question is there any part of your suggested forest management approach that would help prevent forest fires? And if not, are there some suggestions out there for how we can do a better job preventing forest fires?
Yes. Well, those fires are spectacular, and they're just terrifying to watch. The thought of having to evacuate from Paradise, California in your car while the fire's raging all around is just a nightmarish scenario. There's been a lot of talk about we need to manage our forests differently. Well, in fact, studies are showing that the forests that burn the hottest are the young forests.
Interesting.
By making all our forests, keeping all our forests young, we're increasing that. Now, if you've ever been done Boy Scouts and Girl Scouts, you know that you don't start a fire with a big log. You start it with a little twig, and a little tree is a little twig, and so they burn hotter and more rapidly. And the trees that are more less likely to burn are the large ones. They have thicker bark. They have roots that go deeper that allow them to draw up water to stay cooler. And so we talk about how we have these fuel loads, and so we want to go in and thin. Well, talking to the people who actually work in this area, they say, well, what that means is the Forest Service and the forest industry goes in, and what do they thin? They take out the bigger trees, because that's what has economic value, and they leave the little ones. So that practice makes it worse. So I'm not advocating we should rake leaves like the president.
No raking leaves.
No raking leaves. We don't rake leaves, but we also don't take out the trees that are least vulnerable, or at least as many of them. And that's why I think we need to manage some areas for product for forest product production, and different forests for carbon and biodiversity. This idea that we can do multiple use on every acre is just nonsense. It just can't be done, right? And so that's my suggestion: is let's set aside some lands as these reserves and other lands for production. And I would call the working forests, the ones that we're setting aside, because they're working for us in many, many ways.
So it's changing that concept of what we're counting as the working landscape. I like that. I really like that. And of course, that answered a bunch of questions. We had a few questions about how do you balance the need for paper and furniture and so forth. And so you've really answered that. There's room on the landscape for all of this. And it seems to me what's so great about your science is it lets us really target where we should be thinking about, the greatest advantage for leaving forests as forests. So, I think that's great guidance. There was an interesting Massachusetts specific question. Let me find it, which is, what tree species in New England are the best for sequestering carbon? And then the second one is, I'm trying to find this. It's something about invasives that, we've got these invasive
Yes.
trees like the black locust and the white pine maybe. And, and is it, does it make sense to just keep those in place or to take them down and replace them with the non-invasive species?
Right. Well, there are, I mean, for example, back in the CCC days in the 1930s, there were a lot of Norway spruce plantations put in and things like that. Most of those actually never did very well. I don't know why there's this passion for this, that a tree, we'd be planting eucalyptus here if it didn't freeze every winter, I'm sure. It's fast growing, but I don't think that's what we want to do. I think another thing we're learning is that we have to be careful about our picking and choosing. That a forest full of diverse species actually sequesters more carbon more rapidly than a monoculture.
Oh, interesting.
Right.
Wow. Yeah.
And we've only just last 20 some years figured out all this important role of these underground fungal networks and so forth, which move nutrients around.
It's so fascinating. If people watching haven't heard this, there's wonderful article about the grandmother trees in the forest and how there's some of the other trees in their own species or otherwise that aren't getting enough nutrients because of the canopy covering, not giving them enough light. They'll actually, through this underground network, help feed them. I think that's amazing what we're learning.
Right. And so we have to be, I think there's a phrase that I like, we've been too clever by half in our management. And in fact, when we do heavy cutting, then not just invasive trees, but a lot of other invasive species come in. There's a great example in the eastern part of the state that has been managed for 90 years. It's filled with invasives. There are forests in the western part of the state that have not been touched since 1850, and they are doing just fine without invasive species. So, we really need to be careful as we make these decisions. But I think we need to make some decisions. I mean, 2.5% protected, that is pathetic.
Yeah.
Right?
Yeah, we could do better. Absolutely. So we've got a question here from one of your old friends, Greg Watson. He asks, have there been any studies looking at the cumulative carbon impact of city trees?
Yes, there have been, Greg, and I know you have done a lot of work in that area when you were heading an organization here in the Boston area. And yes, urban trees obviously don't grow as densely as trees in forests, but they work in a couple of different ways. One is they obviously store some carbon, but they also provide shade. And so a shaded street doesn't get nearly as hot just from the shading as does an open street, number one. So you don't have that black radiator running down the middle of the street, radiating heat in every direction. And secondly, they evaporate and they transpire and evaporate water, and that takes away heat as well. So a neighborhood that has trees in it will be anywhere from 2 to 5 or 6 degrees cooler than the next door neighborhood that doesn't have the trees, just from the evaporation of water.
That's amazing.
And then if they're deciduous trees, the leaves come off in the winter. So if there's any sunlight, you can capture that. That warms up your house a little bit. But in the summer, it shades it. So I think there are really smart things we know to do with trees. And it prevents some flooding, because when it transpires, sucks up water and evaporates it, that's water that doesn't run off and cause flooding.
So I know in the Nature Conservancy right now, we're really thinking a lot about environmental justice and how we could be helpful as an organization in our urban spaces. And urban trees are critical. It's if you think about what neighborhoods have a great treescape and which don't, it falls, based on socioeconomic and racial lines. And we could, in Massachusetts in particular, really it's everywhere, but in Massachusetts, it's something we could be doing much better, thinking about our gateway communities, and can we get, and of course parts of Boston as well, where there's not that same access to green space and the benefits of trees. So that's a great question. We also got a question from our board chair, Jim Richardson, of course, one of your big fans. In an old forest, what percentage of the carbon is in the soil versus how much is in the trees or the vegetation that's above ground?
That's a really interesting question. And again, we've suspected, we've got some measurements from the past. We now actually have technology that's helping to really answer that. And in a really old forest, there can be, on per acre, half the carbon is in the soils, because the centuries of leaf or needle drop that decay and become soil carbon, sort of nature's composting, builds up that. And when you're in some of these old groves, like the one I showed you that I was standing in, the ground is not the ground you're used to. It is like walking on almost a firm mattress. It just
very cushioned. Yeah,
very cushioned as you go along. It's quite amazing. And if you poke down in there, it's not just plain old dirt. It's real soil.
Whenever I go walking in an old growth forest with my husband, he just wants to take a nap. We get that, and I bring a book now, because I know he's gonna, after about 15 minutes, say, can't I just lie down? And because that is really, I had never thought about that. It's because of all of those layers over the many years. We have a few questions that are similar, asking about how do we create incentives for landowners, forest owners, to let the forest grow? Are there examples of states providing tax incentives, or are there some kinds of economic incentives? One of my old friends from Vermont, who served on the board there with me, Alan Clark, noted that in Vermont there's a current use program which greatly reduces tax on forest land, but only if you manage it, and that means managing it for timber. Right. Is there, do we have some examples of other ways to do it?
I might just say every state that has forests has that law. The forestry industry was brilliant in getting that passed. We'll pay you to keep it in forest as long as you cut it down.
Yeah.
Right. And there is a provision in Chapter 61 in Massachusetts that can be interpreted as alternatively keeping it for other public purposes, which could be construed as being conserving it for other purposes. There's a movement afoot to have a law passed, and I believe it's now been introduced in this new session of Congress, of the legislature, rather. It was last year, it didn't go anywhere, that would basically pay people to keep their forests standing. And it's payment for ecosystem services. And what are those services? A standing forest, for example, is absorbing carbon. And therefore, I argue that should not be a local property tax abatement, which harms the community that it's in. That is benefiting every citizen in Massachusetts, just as much as putting solar panels on your house or insulating your house better, or things that we get subsidies for today. And so in Brazil, they have a plan. The Woodwell Center is involved in this. They did a lot of research, and basically what they found is that farmers were willing to leave some of the land, the trees standing, for a small monthly payment, right?
Yeah.
And having that ongoing income, as opposed to once every 50 years, I cut this down when I have a grandchild who's going to university or something in order to get the money to pay for it, or for an outrageous medical bill I just got. That really changes the whole dynamic. And in Brazil, it's viewed as the donors of this money, the payers of this money, are renting the land to grow trees. Right. So there are different ways of thinking about it. And I think it would be really good. And if we talked about strategic forest carbon reserves, by analogy to the strategic
I love it.
oil reserve.
Yep. Yeah.
you basically then have, and there's subsidies given for that
Right,
to
right.
make climate worse. Okay, how about getting subsidies for doing the opposite with our forests?
Yeah, I think that's really smart. We have a couple of questions sort of with an obvious answer. We have a few people who asked about solar, because one of the things that's obviously alarming to folks who understand the value of, trees is, when a solar developer comes in and cuts down a lot of trees to put in solar panels. And, I assume you agree that that's a mistake.
Yeah, I'm a great solar advocate. I live in a solar house. I've lived in it I'm in my 14th year now.
Nice.
And little over 2 years ago, I bought a solar powered car because I charged my battery powered car with my solar panels. I had to add a few panels to do that. I think solar panels are fantastic, but there's no purpose in cutting down forests to put them in. And I've raised this with the state in numerous ways. I think I've found that a group of us have finally got their attention. I've received the ire of some of the solar advocates,
Yeah.
but I have to plead that I favor both. And I've discovered in some communities, there are people who are called the cleans and the one who are called the greens. The cleans want to put up solar panels, even if you have to cut down every tree in town. That's the extremist position. And the others want to have trees. No, even if you'd never take down a single one to have a decent solar thing. So, yeah, let's kind of work away, push those out of the, let's get those off the table, and let's get to the middle here, where there are times when you may have to take down one tree or two trees to get a solar array in, but cutting down a whole forest to do it.
It does make sense, yeah.
Half of the 34 projects in Massachusetts, in Western Massachusetts, in Berkshire County, have cut down forests of the big arrays.
Wow.
We have landfills. We're doing pretty well in landfills. There are brownfields that are just too expensive to clean up. Pave them over with solar panels, right?
Yeah. And big box store rooftops.
Rooftops.
That can be very successful.
Right.
One of the things that our team does, at the Nature Conservancy, I think that's really helpful and important, is really look at the landscape to say, there's more than enough room for everything on the landscape. Yes. There's more than enough room for the solar that we need, at least for now. I mean, you can think about the plans for the build out, and there'll be other technologies that come into play to offset the pressure. But at the moment, there's no reason to be pulling down forests. There's enough spots.
Or I even heard somebody say, how about building them over wetlands?
No. Don't do it.
Well, wetlands are wastelands by definition in many people's minds, right? And they don't understand the vital functions they perform, like preventing flooding and storing carbon. And they store more carbon per acre than anything else on Earth.
When I was secretary in Vermont, the Secretary of Natural Resources there, we had a lot of conversation about farm fields and prime ag soil, because that's also complicated, where there's only so much farmland available. And then we found that you could actually plant pollinators under the solar panels, and you could also graze sheep and other animals. So there are places of compromise, but I would agree with you, cutting down swaths of forest is not one of them. So there's a question. Dear Bill, this is from Paul Backstrand, and Dear Bill, has the 30 by 30 leadership recognized this reality regarding forests? If so, are they considering declaring no cutting in the national forests? So we've got this new, for folks who don't know, one of the great things that the president has done in his first month is he signed his executive order joining the world in this goal of conserving 30% of land and water by 2030. So
well, I'm afraid, unfortunately, the answer is no. And there's a large group of scientists who are desperately trying to reach the officials in Washington to get them to understand this. As you may know, the U.S. Forest Service is planning to cut 13% of the forest of the Green Mountain National Forest, including massive clear cuts, based on a plan that's 15 years old.
Mm.
And when carbon was not an issue and biodiversity was mostly about wildlife, you know, the few species that are hunted or the few species that bird watchers care about or something. And so it's just a terrible plan. I gave a presentation in Vermont about a week or 10 days ago. And I mean, people up there are really up in arms about this. Yeah. And they want to.
So there needs to be greater alignment. In other words, we're not
quite there. Greater alignment. The short answer is there needs to be greater alignment. So anything you can do, and I'm sure Senator Markey will understand, and I'm sure that Senator Warren will understand, and most of our congressional delegation will understand. So let's let them know.
So I lost track of time. I apologize to everybody with questions that we didn't get to. There were just so many of them, but this has been a fabulous conversation. And it sounds like, you know, you ended with an idea for, you know, people said, what can we do to help? Talk to your legislators, talk to your congressmen, you know, make sure people know that you care about this issue and, you know, continue to learn more. We're first of all, thank you so much for joining us today. And I just want to thank everyone who tuned in for your support of the Nature Conservancy. Your support's what makes all of this work possible. We will be sending everyone a follow-up email over the coming days with links to the resources we talked about today and a recording of this webinar. And of course, if you're enjoying our webinars, feel free to share them with your friends or make a donation to support our work. You can donate via the link in the chat. You can also follow us on social media at conserve_MA on Facebook and Instagram to keep up with our work and to get updates on upcoming virtual opportunities to connect. Please join us on March 11th. We'll be joined by Renee Vassilos. She's the Nature Conservancy's Director of Agriculture Innovation. Renee will talk about TNC's work in the regenerative agriculture space and the innovative solutions that our science indicates are critical for rebuilding soil health, on the same theme of, you know, these ecological services that can come from our natural systems. As always, you can find the latest webinar schedule and register at nature.org, MA webinars. And thank you again for joining us. And one more time, thank you so much, Bill. And thank you for your leadership coming out of Massachusetts. We're proud that you're ours.
Well, I'm proud to be part of ours.
And please keep up the good work. And next time you're with them, please say hi to the Dalai Lama and gratitude.
I'll try to remember.
I wanted to ask you about that experience, and we just didn't get to it. But I just it must have been phenomenal.
It was a trip, as they say. It really was.
We'll put a link to it for folks when we send out the email so you can watch it yourself.
Okay.
So, thank you very much, everybody.
Okay. Thank you. Thank you all.